So actually we are discussing the push-down automata. Let us see some more complex examples. We have seen the DPDA for this language, XC, XR. Let us see some more complex language of Palindrome. So we have the L2. Now you can see that this is also the language of Palindrome, XC, XXR. What is the difference in this language? We don't have the C here. We have only the sigma. Here you have the sigma. Every sentence of this language consists of only the two symbols A and B. This is one thing. We have seen the PDA for this case, and that was the DPDA we have seen. DPDA we have seen. Now, if you go for the language L2 XXR, X belongs to AB clean star. X, so this is what? You may have some string. The string of this language will be like this. You have, say, if you have the A double B, if this is X, if you have the X which is equal to A double B, then we have XR is equal to double B A. This means we have the strings A double B, then we have double B A. This is the input you can supply, and this is the valid input for your language. Now, whenever you are going to construct the PDA for this, the language that has the sentence like this, so how would you know that you need to match? Because there is no marker at the midpoint. So how would you know that, okay, we have arrived at the midpoint? Say, just like looking at this sentence, you can say that this is the midpoint. And what you need to save this part onto the stack. Whenever you are reading the double BA, you have to match whether this is the reverse of this part is or not. But question is that how would you know that this is the midpoint we have arrived? Machine can't know. Machine knows only, machine reads from left to right. It reads the first symbol, this is A, then it goes for the next symbol B, then again B. How would the machine know that, okay, it does not know any information, means it does not know the length of the strings. And there is no way to measure the length of the string, because once you read from left to right, you cannot come back. So the reading is done from left to right. So you have to read, you cannot come back. So how, this is the biggest question in this language. How can you identify that you are reading the string, you are reading the symbol? Say, if your machine is going to read the symbol like B, this B. Whenever you read the symbol this, actually this is the last symbol of your first half of the string. And your machine, your PDA is required to save it. Okay. But how PDA will know that, okay, this is the last symbol of the first half? It may go for the reading the input B. How PDA comes to know that, okay, this is the first symbol of the next half, so that I should not consume and I can transit the state, just like we have seen in case of the, whenever you have the marker C, and you know that, okay, we don't require to save the C onto the stack, just you read and transit the state. Once you transit the state, then your next job is to match the symbols. Here, how would you know that this B you are reading, your machine is reading the B like this, and this is the first symbol of the next hop? How can you identify? As you are moving from left to right. So there is no way actually to identify whether you have arrived at the midpoint or whether you have not arrived at the midpoint. Just like you can see, you are sitting inside the room. You have the room like this, okay? You have the room and you are sitting at this point. You may be at here, okay? And you may have the chair like this, okay? And you are sitting in this chair, okay? And you may have the gate here. You may have the gate so that somebody can enter to your room, and students are coming. So here, see that you may have the long queue. Okay. Here you may have the long queue. Okay. Like this. You may see that, okay, there is a queue, but you are sitting inside the room. You cannot see the queue, how long it is. You are just, some students are coming, entering through this gate, and it comes to like this. And you know only this candidate. And once the task is finished, this candidate, you leave this candidate, and there may be some exit room, say for example, somewhere here and or here, and your candidate goes out. One by one, you are observing the candidates. You are doing some kind of jobs. You may take some interview. You may interact with or you can interrogate with the students. And one by one, students you are going to receive. And then students leaves. But how would you know that, okay, whether how many students are remaining here, because you cannot see outside of the room. You just see the input you are reading. This is the input you have. So if it may be possible that you have some students here, you may require to identify the first half student, and then next you may want to divide the students in two groups. One is the first half and next one is the second half. For some particular task you may be assigning, but how would you know that this student is the last student of the first half, or this student is the first student of the next half? How would you know? There is no way to identify, because just students are entering the room and you are unaware of the queue. This is the queue you have. You don't know how long this queue is. And once you leave, once this student goes out, you leave one by one. And you can't access again that student. So this is the same problem here you have. Your computer, your PDA is going to read the input starting from this, just like the student. And it need to know that whether this input is the first symbol of the next half, or this input is the still in the first half, so that I require to save it. But there is no way, only it can make the guess. This may think that, okay, machine, your machine may think that, okay, this input, your machine is going to make the two possible guess. One is the input it is reading, the input is still in the first half. If it is in the first half, then actually what you need to do, you have to save onto the stack. So you have the stack and you are going to save. You have the stack memory because you need to match. So whenever you have the stack, if your machine says that, okay, yes, this is the first symbol of the first half, you need to save. If your machine says that, yes, this is the first symbol of the next half, you need to save it. If your machine says, yes, still this is the first half, you need to save it. But this is the guess actually you are going to make. Your machine can make other guess also. This may be the first symbol of the next half. Once this is the first symbol of the next half, you don't require to save it. You just transit the state and you don't require to consume the input, so that you can match whatever you have stored. Like if machine is making the correct guess, then for this input, machine should make the guess that, okay, yes, this is the first symbol of the next half. And once this B is the first symbol of the next half, then you don't require to save this. And also you don't require to read this input. You just observing the null transition, you transit the state. And once you go for that state, then you can start reading the B and you are going to match. One by one, you are going to match like this. Okay. So this is the only possibility your machine has. Otherwise, your machine can't identify uniquely whether this is the midpoint. So this is the palindrome language where you don't have any kind of marker. And for this case, you are unable to construct the PDA, which is the deterministic. In earlier case, once you have the language L1, you know that C is the midpoint, and machine knows that once C comes, machine is going to change the state. But here there is no marker. Machine has, the only way remains is you need to make the guess. So whenever you are going to make the guess, This is the case of non-determinism. So for this language of palindrome, you can't have the DPDA. You don't have the deterministic PDA, but you have the PDA, which is the non-deterministic. So how you can construct the PDA like this? How you are going? Your machine is going to make the guess. So see that you have the two possible guess. Okay. So you are going to make the guess. Machine is going to make the guess, and what is the first guess your machine is going to do? Machine says that yes, the input is still in the first half, and hence it requires to save, as you need to match, because you need to match later on. So once you see that input is still in the first half, then machine needs to save, because you are still in the first half. So machine needs to save. Second possible guess is input symbol is the first one of the next half, means this is the first symbol. You can see that. You may write a symbol. Okay. So it is the first symbol of the next half. What you need to do? Then you don't require to consume the input. Then no need to consume the input. What you need to do? Just transit the state. Without consuming the input, just transit the state. Transit the state. As it requires, actually, it requires to match it. Okay. This is. So once your machine says that yes, the input symbol is the first symbol of the next half. So this is the first one of the next half. So like you have, this is the first symbol of the next half. So what you need to do? You don't require to read this input, means don't consume it. Without consuming the input, you just transit the state, because you need to match this symbol. So then no need to consume the input, just transit the state as it requires to match. Okay. So this symbol is needed to match it you have earlier saved. So with this intuition, you can construct the machine. So how you are going to construct the machine? You can start from the initial state. We have to start from the initial state, which is this is the Q0. This is the initial state we have. And we have the input symbol, either A, B, like B. This is the input you may have. We don't have the midpoint, but with the assumption that the input is in the first half, by first assumptions, which says that input is still in the first half and we need to save. So you need to save it, the input onto the stack. So just like you have seen the XC XR, the transition will be like same, because so whenever you are at the state Q0, your input can be A, and top of the symbol is Z0, then you will have the AZ0, by assuming that this input is this in the first half and you need to save it. So you are saving it onto the stack. Next possibility, your input can be B and top of the stack is Z0 and you need to save it, VZ0. Okay. So you have the next possibility. Your input can be A and top is B. Since this input is still in the first half, you need to save it. So A will be in the top of the stack. Again, you can have the input A and top can also be A. So you need to save. Other possibilities, you may have the input B and top can be A. Again, you need to save. So A can be replaced with B. B will be in the top. Next, you may have the possibility that the input is B and top can also be B, and hence you need to save. This is with the assumption that first one. You are going to assume that, okay, this is the first situation, means the input is still in the first half. This part is in the first half, means input is first half, and you need to save onto the stack. So once machine is going to make the second guess, the guess is like this. Your input, machine is going to read the input, and it assumes that, okay, this is the, for every input machine can do like this. So when machines thinks that, okay, the next input, the input I'm reading currently is the first symbol of the next half. If it assumes, then it transits the state without consuming the input. So you can say, for the second guess, what machine is going to do? For the second one, machine think that machine is not going to consume the input, means it don't require to read the input, means it assumes the null transition. So when you assume that the next input you are going to read, this is the first symbol of the next half, then you don't require to consume the input, just transit the state. So whatever be the top can be what? You can have the situation like top can be Z0, top can be Z0, and you don't require to change the top. Okay, so this can be Z0. Next possibility is what? Top can be either A, so you don't require to change the top. Next possibility is top can be B, and you don't require to change the top. So by assuming the second guess, what you come to know that the input you are reading is in the first symbol of the next half, and hence you don't require to consume it, you need to change the state. So whenever you are reading the input A, and you think that, okay, this is the case, if machine is going to make the correct guess, then for this B, machine thinks that, okay, I should not consume the input, and I have to just, without consuming the input, means assuming the null transition, I should transit the state. So assuming the null transition, top can be A or B. So by assuming the null transition, top can be either B or top can be either A, it goes to the transit the state. Okay. So for the first input also, machine can make the guess like this. If your machine is going to read, okay, for every input actually, it is going to make the guess. What is the smallest possible strings can be? Your X can be null also. When X is null, then also you have the transition. If there is no input, your input is null, string is null, then top will be Z0, null top Z0. So see, for every case, you are assuming this is the transition for assumption that this A is in the first half, and you are going to save. See, top is Z0, and for this top you have specified the null transition also. This means you assume that this is not in the first half, it is in the first symbol of the next half. So you don't require to read this input, and you just transit the state. So this is the next assumption. For this B, also the same. For C, this is the situation where you assume that A is in the first half. If A is in the first half, so what you have done, you are going to save A onto the stack, and A will become in the top, and you remain in the same state. This is one assumption. But for the same top B, you have also specified the transition like this. So if machine has choice, for this top, you have specified the null transition also. So machine has choice whether it can go for this option or whether it can go for this option. Once machine is going to assume these options, means machine is not going to read A, because machine understand that this is the first symbol of the next hop, and hence I don't require to consume this input, because I have to match it again, and it just changes the state. You have top is A, and for this top A you have specified the null transition, means machine is going to make the guess. Here machine says that okay, yes, this input is in the first hop and I need to save it. Here you are saying that the input is not in the first hop, it is the first symbol of the next hop, so I don't require to consume it. Without modifying the top, I should transit the state. Okay. So this is the way your machine is going to make the guess. And whenever you are at the state Q1 now, this is the state Q1. So whenever you are at state Q1, the job is your simple, because you come to know that machine, once you are at the state Q1, means machine knows that you are in the second hop. And what is the job of second hop? It is the matching. So you have this, you have to match it, means input is A and top must also be A. You are going to delete. Input is B and top is B. You have to match it. This is this. When your input exhaust, you have matched whatever you have saved, you have matched, and top becomes at 0. Then you go to the final state and say you are going to the final state Q2. So here you have the Q2. This is the final state. Okay. So see, this is the PDA for the given language XXR. Okay. So for the language XXR, where X belongs to A, B, 10 star. For this language, you have the NDPDA now. So this is the way you can construct the PDA for the language XCXR. So this is what, here you have the null transitions. In presence of the null transition, this machine becomes the non-deterministic. And for the language XCXR, when at the midpoint you have the C, you have seen that even null transition was present there, but machine was deterministic. So this is the non-deterministic PDA for the given language. Now, whenever you have some language, like you have the L3, for example. Now see, this is also the language of Palindrome. Now here, this is more complex and more general language. Why it is so? Because your string can be of odd length or your string can be of even length. Earlier you have seen that every string was having the even length. You have seen this language. So here now we have more general. This is the language of Palindrome over the alphabet A and B. And your string length can be odd or your string length can be even. So say this is more complex language, means this is more general language of Palindrome, or you can say that this is the Palindrome language over the alphabet C. So language of Palindrome over A and B. So you have the alphabet and symbol A and B, and this is the language of Palindrome. Now, what will you do? Here you have the more complex guess. The string can be of this is also valid in this case. Okay, this is also valid in this case. B is also valid in this case. This is also valid in this case. B is also valid. So some strings may be of having the even length and some string can be of odd length. So this is the even length, you have the odd length. Okay. So this is more complex language of the Palindrome. What will you do for this case? Here, this is not the case of identifying the first hop. Just like in case of the even length string, you have identified the first half of the symbol. So here you can have AB, BA. This is the actually even length string as we have seen earlier, and you have done by identifying by guess that okay, you consider that this is still in the first half, you require to save, and this is the first symbol of the next half, you don't require to save. You transit the state without consuming the input, and later you need to match this symbol with the stack symbol. So this was the assumption. Now here your string can be of odd length. Once your string is of odd length, then what you can do? You are reading the input, so you have to make some more complex guess. Machine thinks that okay, now machine is going to make the 3 guesses here. Machine required to make the third guess also. What third guess? Machine thinks that the next input it is going to read, this is the midpoint, this is the mid symbol of the odd length string. So machine should also guess that the input it is going to read, this is the mid symbol of the odd length string. And if this is the mid symbol of the odd length string, just like you have the mid symbol C in the XC XR, whenever you have XC XR. So this was the midpoint. So here also you assume that, like if you have the odd length, you may have the odd length string. So machine should assume that okay, the symbol I am reading, this is the midpoint of the mid symbol of the odd length string, and hence what you need to do, you need to read this symbol, but you don't require to save onto the stack and just transit the state. So this is the guess you need to make in addition to the first 2 guess. By seeing that the symbol you are reading, you believe that this is still in the first half, and you require to save it because later you need to match. Or the symbol you are going to read, this is the first symbol of the next half, and hence you are going to, once you may have the even length string, and you think that okay, this symbol is the first symbol of the next half, and hence you don't require to read it, you just transit the state for matching purpose. So here machine is going to make the more complex guess for the language of L3. So when you have the language of palindrome over alphabet AB, over the symbol AB, and the length of the strings can be of even length or can be of odd length. So what you can do? So how you are going to make the guess? So here machine is going to make the much complex guess for the case of the palindrome language. So here you have seen that this is corresponds to what? This is corresponds to the guess 1. So your machine is going to make the first guess that okay, the symbols are still in the first half and we need to save. So this is corresponds to the guess your machine is going to make. This is corresponds to the guess your machine is going to make for the guess 1. What is the guess 1? Machine thinks that okay, yes, machines think that okay, this is the input is still in the first half, and hence it requires to save it because later you need to match. Once you make the second guess, this is the second guess you have. Second guess says that you are reading the input and which is the first symbol of the next half. So you don't require to, you may have the even length string and you are reading the input which is the first symbol of the next half. So don't require to make the, don't require to consume it, and without consuming, you just transit the state. So this is corresponds to what? This is corresponds to the second guess. Your machine is going to make the second guess. Okay. So, or you just write here. This is the second guess. And here, machine is going to make the guess 1 as corresponds to this. Now you are going to make the third one also. machine is going to make the third guess also. What is the third guess? Machine thinks that the input symbol it is going to read, and this input is a mid symbol of the order length string. And what you need to do? You need to read this input, and simultaneously you have to transit the state, because you have to match the next part. So what can you have? So whenever you are having the situation like this, the machine may think that, okay, yes, I will. So say input can be your input can be what? Your input can be A, and for this input, machine thinks that, okay, this is the mid symbol of the second half. Then it is going to read this input, and without changing the top, it is going to transit the state. So it is going to read this input. Once machine understand that, okay, yes, this is in the first half, and I don't require to save this input, just I need to read and transit the state, because this is the odd length string and I have to match the next part. Similarly, your input can be A, and top of the symbol can be, your top of symbol can be either A also. When top is A, you assume that we are not going to change the top. Input can be A, and your top of the symbol can be what? The top of the stack can be B. So you are not changing the top, just you are reading the input and you are going to change the state. You can have the input B, and the top of the stack can have the 0. So you assume that this B is the midpoint of the order length string, so don't require to save it, and without changing the top, you are transiting the state. Okay. Now your input can be B, and your top can be A. So your top can be A, and without modifying the top, you are going to change the state. So your input can be B, and top can also be B, and without changing the top, you are transiting the state. You are reading and transiting the state. So this is what? This is corresponds to the guess third. Your machine is going to make the third guess. So what is the third one? So you have the guess third. What is the third guess? Machine assumes that the next input is the mid symbol of an odd length string. Okay, and hence it reads this input and without modifying the top and change the state. So it reads this input without modifying the top and transit to the state, next state. Okay. So see that you have the 6 conditions corresponds to every this. You have the 6th one, right? So A is at 0. So say that now here input, the transition you can look. The transition, you are at the state, say for example Q0. If you are at the Q0, and say input is A and top is Z0. What is the output of this transition? So you have the output. This is one output. You are in the state Q0. Input is A, top is Z0. What you do? You are going to replace Z0 with AZ0, and you are still in the state Q0. So this is the Q0, and what is the modification you have done? The top of the symbol becomes top of the stack. You are replacing with the strings AZ0. So for this input Q0 AZ0, you have this one output. See, you have other output also. This is one output. What is the other possibilities? You are at the state Q0. You are at state Q0. You are reading the input A. You are reading the input A, and top becomes Z0. This is condition. You are in the state Q0. Input is A, top is Z0. What is the output? The output is what? You are going to the state Q1. You are going to the state Q1. And what is the top? You are not going to change the top. You have the top symbol is replaced with the again Z0. So this is the next possibilities. So for the same input, for this input, this has the two output. One is machine can go to this possible output, or machine can go to this output. When machine is assuming this, then it says that A is in the first half, and I'm going to save it. When machine is going to assume this, it means the input is in the midpoint, mid symbol, and I have read this input, and I'm transiting the state because I have to consume it without changing the top. So every transitions here, you have found that every 6 transitions have 2 possible outputs. And clearly you know that whenever you have more than one output, this is the set, this denotes the set, and cardinality of this set is what? Cardinality of this set is 2. So cardinality of this is what? Cardinality of this set is 2. So you know that clearly this machine is non-deterministic. And in other way, you have the null transition also. For the same top, you have specified the transition for the input also, and hence this machine is highly non-deterministic. So for the case of the language, we have for the language L3. What is this L3? This L3 is the language of Palindrome, which over the alphabet A sigma, which contains only the 2 symbols A and B. So X is equal to AB clean star such that X is equal to XR. And this is the PDA for this language, and this PDA is what? NDPDA. NDPDA. ND means non-deterministic push-down automata. NDPDA. So you have obtained the NDPDA. Even you can see that this is what? This is the context-free language. You can construct the context-free grammar for this language. You know that. And this is the context-free language. But this context-free language, for this context-free language, we don't have the deterministic PDA, but you have only the NDPDA. And also, just like we have seen in case of finite automaton, NFA, every NFA can be converted. We can found for corresponds to every NFA, we will have some equivalent DFA also. But here, there is no algorithm available that you can use for converting the NDPDA, non-deterministic push-down automaton, to the deterministic push-down automaton, DPDA. And hence, these 2 machines are not equivalent. Means you cannot obtain the DPDA, deterministic push-down automaton, equivalent to the NDPDA. There is no algorithm that can convert. And you can say that the power of NDPDA and power of DPDA are different. Why it is different? Because NDPDA accepts the different kind of language, and DPDA accept the different language. DPDA accept the context-free language also, and NDPDA also accept the context-free language. But language accepted by the DPDA is also known as the deterministic context-free language. And deterministic context-free language are the proper subset of the context-free language. So here you can observe that the power of NDPDA is more as compared with the DPDA. So for every deterministic context-free language, you will have some DPDA. And for every DCFL, deterministic context-free language, you have some unambiguous grammar. So you have, for every deterministic context-free language, we have unambiguous grammar, means we have only one leftmost derivation tree if you go for the parsing. So here you have seen now the power of these two machines, NDPDA and DPDA. So you have the DPDA, deterministic pushdown automata. So power of DPDA is not equivalent to the power of NDPDA. And this is the one example where you can see that we have the NDPDA. This is for the language L3, which is the truly palindrome. The string can have even length or odd length. For this language, we have the PDA, which is non-deterministic. Okay, and we can't obtain any deterministic PDA for this language. And this says that the power of these two machines are different. Means DPDA is not equivalent to the NDPDA. They are accepting the different classes of language. Even the language accepted by the PDA, whether it is the NDPDA or whether it is the DPDA, are the context-free language. Okay, but deterministic context-free language are the subset of the context-free language. Like you have the programming language. This is the deterministic context-free language because the grammar for this language is unambiguous. You have the sentence where you have the clearly identified what you mean by the syntax of the programming language. Machine don't require to make the guess. Okay, so this is in these two examples. We have seen that for the examples L2 and L3, you have seen that we can obtain, although these are also the context-free language, but we have the NDPDA instead of the DPDA, and also there is no any particular algorithm that can you use. You can see one more example. We have the language, say we have the language L, and L contains the set of X which is taken from the AB clean star such that the length of A in X, okay, means length of number of A in X, you can say number of A in X is greater than number of B in X. So number of A in X is greater than number of B in X. So you have the number of B. Okay, we have the language like this. So you can list any value string of this language. So we have the language for this language. What are the value string? Number of A is more than number of B. Means you have only single A. This is valid because the number of B in this sentence, the number of B, how many B's are there? X contains only single A, means you have the 0 number of B's. So this is, you have the more number of A as compared with B. You can have AAB, this is also valid string, or BA, this is also valid string, or ABA, this is also valid string. Why it is so? Because number of A in this string is more than number of B. So here number of A is more than number of B. You can also have this valid string, number of A is more than number of B. So these are the sentences of this language. Question is that how can you construct the PDA for this language? So we need to construct the PDA for L. So we need construct a PDA for the language L. So we are going to construct the PDA for this language. How you can obtain the PDA? So you need to, there is a very simple way you can say. What you can do, you can just start from the Q0. You have the Q0. Your machine start from the initial state, which is the Q0. And what is your job? You just see that your input can be A. Okay, your input can be A, and top of the symbol can be Z0. So what you need to do? You just save it onto the stack AZ0. Next possibility is you can have input is B and top of the stack can be Z0. You need to save this. This is one. Other one is you can have input is A and top of the stack can also be A. So what you need, you have to save it. Other possibilities, input can be A and top of the stack can be B. What you need, when alternate combinations comes, you need to delete it. Similarly here, when you have the input is B and top is B, what you need, you need to save it. Whenever you come to know that input is B and top is A, delete it. When you have the alternate combination, you have just deleted. So see, if you are given some input like A, B, A, B, A, like this, so what you need to do, whenever you read, you have the stack, at present you have the stack like this, okay, and you have at the bottom you have the Z0. Whenever you have A, top of the stack is Z0, so you can assume this transition and read this input and your top will becomes now this. Whenever you have B, input is B and top is A, so you can see input is B, so you have the input is B and top is A, means alternate, so you are just going to delete this. Now input is A and top can be Z0, you are going to save it. Now input is B and top is A, so input is B, top is A, further alternate combination, so you have to delete this symbol. Now input is A and top is Z0, so you have the A, save onto the input is A and top is A, save onto the stack. So input is A and top is A, same symbols. If you see that top of the symbol is same, input is top of the symbol is same as the input symbol, you just save it. So once your input exhausts, there is no input. When your input exhausts, then what you need to see? You need to see the top of the stack. If top of the stack is A, then you have more number of A's as compared with the number of B's. So this is the condition where you see that if input exhaust, when input exhaust and top of the stack is A, then what you need to do? When top of the symbol is A, you may not modify this, you can leave it as it is, and you just transit the state, you can go to the state Q1, and this state Q1 is the final state you have. This is the final state. And that's all. So this is the PDA for accepting the language X over the AB clean star such that number of A in X is more than number of B in X. So what you have seen, whenever you are just reading this, you are reading the symbol and saving onto the stack. Whenever you see that the input symbol and the stack top symbol are opposite, different, A and B, then you have to delete it. Matching is done. Whenever you see that top symbol of the stack is same as the input symbol, means save it. So once your input exhaust, you have to see that what is the top. If top is A, this shows that you have the more number of A's as compared with more number of B's. If top is B, then this is the reverse case. If your input exhaust, like you have A double B, so for this case, you have at the bottom you have the Z0. When you push it, this is A. When you read this input, alternate combination, input is B and top is A, delete it. Then you have the B, Z0, you have top is B, input exhaust, and you see that top is B, means it is guaranteed that once top is B, below this top, next top to top, you have also the symbol either B or you have the 0. You can't have the opposite symbol, because once you have the opposite symbol, means opposite in this case means you have the A and B, only two symbols, and you are going to match these two symbols. Whenever you see that opposite conditions, input is A and top is B, or input is B and top is A, then you are going to delete this. So that's why it guarantees that whenever your input exhaust, and you can decide on the basis of your top symbol. When top symbol is A, means you have the more number of A's. If top symbol is B, means you have more number of B's. So this is not the case of acceptance. When top is A, this is the case of acceptance. That's why you have to show only this kind of transition. Other combination, when input exhaust top is B, you don't require to show this transition, because you don't want this transitions. But see, you have seen that the top symbol is A, and the top symbol is A here also, and top symbol is here. You have the top symbol is, this is also A. So this is also A. Okay. So you have input is B and input is B and top is A. So you have the top A, input is B, top is A, you are going to delete. So this is the top symbol for which you have assumed the null transition. For this is the top, you have given this kind of transition, and for this top you have given this transition. For the same top, you have specified the transition for the inputs also, other inputs A and B. This means machine has a choice. If top becomes A, then machine has choice whether it should consume the input, or without consuming the input it can transit the state, because top is same. So machine has choice. So this is actually NDPDA. This is the NDPDA. So this is the NDPDA for this language. Okay. Now question is that, can you construct the DPDA for this language? Can you go for the DPDA for this language? So yes, for this you can think, and it is possible to construct the NDPDA for this language. What you need to do? See, whenever you are at the state Q0, you have the state Q0, you still need two state. You are at the state Q0, okay, and you have the state Q1. This is the state Q1. You have two states, and Q1 is the final state you have. Okay, this is. So what you need to do, as soon as you identify you have more number of A's, you just transit to the final state. To see, if you are at the state Q0, and when you come to know that input is A, and top is Z0. This means what? You have reading the first input, which is the A, and you have more number of A's as compared with B. So transit the state. You are at the state Q1, and you don't require to save this input. So you have top is remains Z0. So whenever you are at the Q1, you are guaranteed that you have more number of A's, right? So, but whenever you are at the Q0, what you guarantee that you have either same number of A and B, or you have more number of B's as compared with A. So you can show the transition for this Q0. So whenever you are at the Q0 and you can have the input B and top can be Z0, then you need to save this. So you have B Z0. So B, you have more number of B's. So that's why you are here now. Now, whenever you are at the state Q0, whenever you are at this state Q0, then you may have the situation that though your input is B and top can also be B. So what you need to just save it. Still, you have the more number of B's. Whenever you are at the state Q0 and you see that input is A and top is B. If input is A and top is B, then you have to delete it. So as long as you are here and as long as you see that your Z0, you may have more any number of B's. Okay. Whenever you some input comes A and you see the top of the symbol is B, so just you have to delete this. Okay. So, but at the state Q0, you will not have this kind of combination that your input is B and top is A. This will not be having the, because once top is A means you have more number of A's and you will be in the state Q1. So that combination will not be there here. So only you have to do three things here. One is you are going to save all B's onto the stack, or whenever you are reading and your input is A and you see that top is B, and you can delete it. As soon as you come to know that you have more number of, you may find some, say you can have A and you are going to delete. Further you can find A, you can delete this. Further you can find A, you can delete this. And further you have A and the top becomes Z0, means you have more number of A's now. You transit the state Q1. This is the situation. So whenever you are at the state Q1 and your input can be B. Once you are at the state Q1 and input is B and top is Z0, this means what? You have just your input is B and top is Z0. You are at the state Q1 and for the first symbol A you are at the state Q1, and whenever you see that at the state Q1 input is B and top is Z0, this means same number of A and same number of B it becomes. So you just go to the state Q0 without saving this onto the stack. The transition for the state Q1, you are in the state Q1, you may have the transition like this. Your input can be A and top is Z0. So you need to save it. Your input can be A and top can also be A. Just save. You have more number of A's. So you are still in the fun state. Other possibilities, your input is A and top is B. Sorry, this kind of combination you will never find in this case. Input is A and top is B will not be there because you have here more number of A's. So what is the condition? So what condition will be here? Your input can be B, but here you may have A in the top. So input is B and top can be A. Here you have seen input is A and top can be B. Here your input can be B and top may be A. So what you need to do? You have to delete this combination. And continuously, once you are going to delete, sometimes your top may become Z0, and when you receive further B and top becomes Z0, means same number of A and same number of B, you are here. So these are the only transitions you need for the state Q1. And hence, this is the way you can say that you can have any A, B, A. If you can have any input, valid input, which has the more number of A as compared to the number of B, once you assume that you will be in the final state. For example, if you have the A and top is Z0, you are going to the state Q1. So whenever you are at the state Q1, you have the input A and top is Z0, you have saved it, right? Whenever you have input B and top is B and top is A, you delete it. So you have deleted it. Input is A and top is Z0. Input is A and top is Z0. So you can save it. Okay. Input is B and top is A. Input is B and top is A. You can delete alternate combinations. And now your input exhaust. Once your input exhaust and you see what is the top is Z0 here, means your input exhaust and you are in the state Q1. You are in the state Q1 means you have more number of A in the string X at least by 1. So when top 0 is Z0, top is Z0, it means you have one more number of A as compared with either if you have you may have if you have more number of A's like this, then top will be, once your input exhaust, you have find this matching, and once your input exhaust, the top will be A. But question is that you will be in the state Q1 when your input exhaust, and if it is the valid string, means when you have the more number of A's as compared with the number of B's, then your machine is going to end up with the state Q1, which is the final state. And hence this is the DPDA. This is the DPDA. This is the DPDA for this language. So this is the NDPDA for the language. We have the language L, which is what? X, which is taken from the AB 3 star, such that number of A in X is more than number of B in X. So this is for this language, this is the NDPDA, and for this language, this is the DPDA. So for the language L, which has more number of A as compared with number of B, we have the two possible PDA. You can have the DPDA also, and you can have the NDPDA. And if you are lucky enough to find the PDA, which is the deterministic, you must go for the deterministic one. So for some language, there is a way to obtain the deterministic PDA also. At the first time, it looks that, okay, you can't have the DPDA, but once you observe the strings on the PDA, then on carefully observation, you may be able to obtain the deterministic PDA for the same language. But the language, like we have seen, the language of Palindrome, for such kind of language, you can't have the deterministic PDA.